for this video, what I want to do is talk to you about a complement of a set. So the complement of a set contains all the elements that are not in the given set. Okay, so different textbooks have different notations. My current textbook uses this notation. So all of the examples that I'm using that notation just to make it easier for my students. But any one of these are acceptable notations for the complement of a set. The first one is a to the c power a prime and tilde a, but no matter what symbol is used, we just read this as not in set A. So it's not in A. Okay, you don't always even have to say the set. So whenever you see these symbols, you're looking for everything that is not in the given set. So if I just looked at set A, 1, 3, 5, 7, and 9, there are a lot of numbers in our real number system that are not in this set. So it could be a very large amount of numbers, or you can narrow it down to where you're dealing with multiple sets. So I have set A is 1, 3, 5, 7, and 9. B is 1, 4, 6, 7, and 9, and D is 2, 3, 4, 5, and 6. I chose not to use C as a set name, even though you can, just because of the symbol that I'm using, but it doesn't matter what your sets are called. Okay, so for this first one, we are looking for everything that is not in B and in D. So remember that this symbol means and. So basically what we're looking for here is everything that is in set D that is not also in B. So I have the numbers 2, 3, 4, 5, and 6. We can see that 4 and 6 are both in B. So those we would want to eliminate. So our answer to this, the not in B and in D, we would just say are the numbers 2, 3, and 5. Okay, so moving to the next one, we're looking for everything that is not in A, but it is in B. So this time we're going to look at B, and I'm going to eliminate anything that I see in A. So we know that A has 1 in common. I tried to switch colors. All right, so we're looking at B, and we know that 1 is in there, 4, 6, 7, and 9. So the only two numbers that are left that we would not eliminate for this one would just be 4 and 6. So 4 and 6 are the numbers that are in B and not in A. Okay, and then for the last one that we have set D. So it's not in set D, and it is in A. Okay, so this time we're going to be looking at my elements in A, and we're going to eliminate any elements that we see that are in D, because we only want things that are in A but not D. Okay, so I would eliminate the 3 and the 5. The 1, 7, and 9 are not in D, so I can just say that this is 1, 7, and 9. Okay, so for this one, we're looking for the elements that are in set A and not in D. So we eliminated everything that they have in common. A lot of times you won't see it like this in a textbook. The textbook that I'm currently teaching from does do it this way. Most of the time you're going to see complement given this way, where you're given a universal set and you're given values for two other sets. So this is known as the universal set. Whenever a U is used, and that's saying those are the only numbers that can be used for this particular problem. So for this one, our U is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so for our first example, we're looking for everything that is not in A. So your textbook could have written this as find A prime, or it could have said find tilde A. Same for this one, it could have said find B prime or tilde B. So all three of these mean the same thing as far as the notation goes, so it's just a matter of preference of the author. I personally prefer either this one or this one, but like I said, the book that I'm using right now uses this symbol. Okay, so what we're going to do is we're looking at A. So we're looking at all of the values that are in our universal set that are not in A. Okay, so I can eliminate basically all of the even numbers for this one. And so the complement of A would end up being 1, 3, 5, 7, and 9. Because in our universal set, 1, 3, 5, 7, and 9 are contained there, but they are not in A. Okay. So for the last one, for B, we're looking for all things that are in our universal set, but not in B. So we could say that BC or B prime or tilde B, whichever one you want to use, we can see that 1 and 2 are both there. So if it helps, you can always go through and cross out, okay, 1 and 2 are there, 3 is not, so that's the first thing that I would write down. 4 is there, so we would cancel that one out. 5 is not in B. 6 and 7 are both here, so we would cancel those out. So we would have 8, we would cancel out 9, and we would be left with 10. So these are all of the values that are in our universal set that are not in set B. And for the previous one, these were all the values that were in the universal set, but not in set A. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like me to cover, please let me know that as well.